Eric Bryan is here now, so
Just let me know when everybody's in from the waiting room.
yep, everybody's in.
All right, great. So let's get started. Thank you everyone for joining us for our CBE Spring Town Hall meeting. Hopefully you're rounding out a nice spring and heading into summer. It's great to have everybody with us. I think we have an exciting agenda today. So we're going to have a couple special guests. Perhaps it was alluded to in the meeting solicitation, but if not, I think we're in for a very interesting meeting. The other thing I would like to point out before I get into the meat of the presentation is to note that we'll go through some updates from the department perspective, and then we'll have a research presentation, and then we'll hopefully hold all questions till the end. So Mike Holland will be sort of compiling the questions that came in when you registered. Also, if you want to just enter them into the chat, he'll be monitoring that and compiling those, and then we can collectively answer those at the end. So just to launch off, we've had a really good spring in terms of faculty recognition. As people know, we have a very highly rated department with lots of great faculty. And so I'm just giving you a sampling of some of the things that have been recognized in the past few months. So Mike Graham is the recipient of the Eugene C. Bingham Medal. So this is the highest honor that you can receive from the Society of Rheology. So it's a really big deal. A who's who in transport phenomena and rheology is represented by the Bingham Medal Award list. George Huber was named a Vilas Distinguished Achievement Professor. And so this is an honor here on the UW campus that's very competitive and really is the highest award that you can receive from the UW-Madison campus. And this honor recognizes not only research, but also teaching and service contributions as well. Marcel Schreier, one of our younger assistant professors, was the recipient of an NSF Career Award. So for those of you who don't know, when you apply as an early career scientist to the National Science Foundation, one of the biggest awards they have there is this so-called Career Award. So this was very exciting for Marcel to receive this award to support his research in electrochemistry. And then I grouped these last two awards together. We not only are renowned for our research, but also our instruction and, the putting out great undergraduate and graduate students that then go on and change the world. And so in that long line of successes in the classroom, I would like to point out that Reed Van Len was the winner of the Benjamin Smith Reynolds Award for Excellence in Teaching. These are College of Engineering level awards. And Victor Zavala was the winner of the Harvey Spangler Award for Innovative Teaching and Learning Practices. And so they're part of a long line of faculty in the department that have won these prestigious teaching awards. How about the undergraduates? So it's a little quieter around here this week because they've kind of graduated. We do have a summer lab that's in session, but otherwise it's pretty quiet around the engineering building. We had about 540 undergraduates enrolled in our program. That includes, from freshman through senior. And 74 of those graduated in May. I shook a lot of hands as they walked over the stage at the Cole Center. And here are just a few shots of how full the room was in terms of all of the families and friends that came out and supported their graduates here at our Chemical and Biological Engineering undergraduate graduation reception. So you'll notice that 3 of them graduated in May and 71 are August graduates. And the reason they're August graduates is because they have to probably complete their last course, which is the summer laboratory, before they officially graduate. In terms of graduate student news, we have a great cohort of graduate students. We're probably at about 120 or 130 graduate students in the program currently. And they're very accomplished. And I'd just like to recognize a few of those accomplishments here to you today. The first I'd like to note is the Ragatz Award winners. These are the instructional TA award winners. These folks are actually voted on directly by their students in their classes as being the best teaching assistants. And so we had 5 winners this year for the Ragatz Teaching Awards. We also had many students get outside recognition in terms of fellowships. Just as a couple of examples, Abigail and Sam were recipients of the prestigious National Science Foundation Graduate Research Fellowship. We also like to internally reward really high scholarship for our graduate students. And so a couple of recipients here of the Bird, Stewart, and Lightfoot Graduate Fellowships are Jiang Wu and David Cole. And we have a sponsored set of fellowships from PPG Industries, and those were won by Libby Brunghart and Kenneth Martinez. And so these are more senior graduate students that have demonstrated accomplishment at the graduate student level. And now for one of our special guests today, I would like to introduce you to the incoming R. Byron Bird Department Chair for the UW-Madison Chemical and Biological Engineering Department. And just to fill people in, I would like to point out that our department historically has had chairs serve 3-year terms. And so my 3 years are coming up to an end here on June 30th. And then the next elected chair will assume the responsibilities of the R. Byron Bird Department Chairship on July 1st, and that's Professor Brian Flagger. So before I turn the floor over to Brian, I'd like to just tell you a little bit about him. So Brian received his bachelor's degree in chemical engineering from Cornell University. He then went on to earn a PhD degree in chemical engineering from the University of California, Berkeley. He followed that with a postdoctoral research stint at the University of Michigan, where he studied enzymology. And what he focuses on now is using microbes to produce value-added chemicals. So he joined us here at UW-Madison in 2007. So he's been here about 17 years. And he's a very accomplished researcher, scholar, teacher, and he excels in service. And so because of those things, he's currently the Karen and William Monfrey Professor and also a Vilas Distinguished Achievement Professor. So at this time, I'd like to just give the floor over to Brian to let him introduce himself. Brian, floor is yours.
Thanks, Eric. That's far too generous an introduction than I deserve. And I have to say, thank you for all that you've done for the department. I'm certainly following in some very, very large footsteps. So I'll do my very best to keep your momentum going. And I hope we can continue to produce the very best chemical engineers in the country. So to the rest of you, it's a pleasure to meet you, at least virtually. I know I've met some of you individually in various places in the past. And as Eric said, I don't have a degree from UW-Madison, but after 17 years on the campus, I'm extremely proud to be a Badger. I've known Badgers at just about every step of my career. As a co-op student at 3M, I roomed with a CBE undergraduate. I had several lab mates in both grad school and my postdoc who were Badgers. They were instrumental in helping me decide to join this department when it became time to become a faculty member. And then certainly as a faculty member here, I've gotten to know people from across campus, whether I meet them here at meetings or in an airport someplace far across the world. So each and every one of these individuals has been outstanding in their own way and expressed a real sincere appreciation for the education and the value of their time that they spent at UW-Madison. And I've heard a lot of the same things from you. And I have to say that your affection as an alumni community for the department is completely infectious. And when we go to recruit new faculty candidates, it's something we can point out that the role that you're going to have in this department is going to affect the lives of people, and they greatly appreciate all the hard work that we put in. So with that infection in mind, I can promise you today that I will continue to foster an environment in which the students that we recruit will have the tools and opportunities to develop into the professionals that our country really, really needs. And so towards that promise, I've got a couple of specific things I'd like to mention. First of all, you may have heard that the College of Engineering is working on a new state-of-the-art engineering building, and we hope to see that emerge and become open sometime in 2028, right across the street here from Engineering Hall. It's a pretty impressive looking facility that will greatly expand the college's capacity as well as its capabilities. And I've had the privilege actually to sit on the design workshops with the architecture firms who've been responsible for its construction planning and contribute ideas to how the facility could impact or be a great place for some of the activities that are related to chemical engineering education, research, and the service opportunities. So as the department chair, I will continue to advocate for a strong CBE footprint in the building and ensure that our students have access to all of those great educational tools and ensure that the department has room to grow. And so the second thing is along the same lines, and thanks to very generous support from alums like you, the department's renovated over 40% of our existing space in Engineering Hall over the last 6 years. So that includes the expansive Kittemeyer instructional laboratories that are going to be the home to Transport and Summer Lab for decades to come. And with those facilities coming online, it's now time for the department to continue its legacy of leadership in chemical engineering pedagogy. And so the faculty and instructional staff are beginning a process to look comprehensively, top to bottom, at the curriculum and trying to find ways to increase the flexibility for students to specialize in things that are important to their career goals without sacrificing all of the core chemical engineering fundamentals that we're known for. And lastly, as you'll see in just a minute here, the department has hired several outstanding high-energy junior faculty. And it's going to be my task to provide them with the mentoring and the support that will allow them to join the ranks of the legendary UW faculty that have been inspirations to students for generations like you. So on July 1st, I'll be taking the reins from Eric. I've been involved in a lot of discussions. Eric's been fantastic in training and getting me ready. And so I know I can count on you for continued support of the department. And if you have ideas, I'd be delighted to help facilitate those efforts to connect you with activities around the campus, around the faculty. So please keep in touch. And I'll close by saying that in my opinion, the department is on an amazingly promising trajectory. And I will do everything I can to ensure that UW-Madison remains a preferred source of chemical engineering graduate students and students for decades to come. So thanks, Eric.
Thanks, Brian. And I look forward to your next 3-year tenure as the chair of the department. So I just had a couple more slides that I wanted to share. Brian alluded to the opening of the John C. Kittemeyer Instructional Laboratories. And these are just a couple fun slides to fill those in who weren't able to join us about the grand opening celebration that we had on Friday, April 19th, just this past spring. We had about 150 alumni join us for the grand opening, and it was probably the only time there's a really big party in the instructional laboratories. Let's just put it that way. But it was a lot of fun. I just wanted to share a couple of pictures. Where we started was a pile of dirt and taking the floor out with a bobcat. Partway down the road, down here in the lower right, you can see there's some work being done on the ceiling. There's some new floor drains being poured. And then just a year later, here we are celebrating the opening of the laboratories. And I'll just take you a little bit clockwise here. So up front here, we did a fun little thing where we wanted to christen the new distillation column. And we did so by combining our collective Badger blood, sweat, and tears, I think I called it. But really it was, red colored water. And added to this communal flask for charging the column. Who you see here, this is Greg Kittemeyer. This is John's son, who was able to join us for the grand opening. There's a nice image from the bottom of the distillation column looking up, some nice red lighting and things that were installed just for that event. And you can see people exploring the space. And then also exploring our donor wall, where we've recognized the many donors that helped make this project come to fruition. And then I didn't let our former chair, Regina Murphy, off the hook. I had her come up and take that charge and then actually add it to the charging funnel here to to the tank that feeds the distillation column. And so it was a really exciting night. And if we walk downstairs right now, we'll see a group of students in those laboratories using them as the first cohort that's going through using these brand new instructional spaces. So with that, I'm going to turn the floor over to Assistant Professor Quentin Dudley to tell you a little bit about what he's up to in his laboratory. So as a means of introduction, Quentin received his bachelor's and master's degrees in biological systems engineering at the University of Nebraska. I've heard that he now has switched his women's volleyball allegiance to UW-Madison, but maybe he might correct me on that when he gets up here. He received his PhD at Northwestern University in chemical and biological engineering, and then followed that with a postdoctoral research stint at the Earlham Institute in the UK. And so Quentin, he's going to tell you a lot more about this, so I won't take away his thunder here, but he is one of the world's leaders at understanding gene regulation in plants, and he's leveraging that in order to use plants as a means for producing value-added chemicals. And so with that, Quentin, I will turn the floor over to you.
Okay, thanks, Eric. Let's see if I can get this shared. There we are. So yeah, with building off that introduction, I'm one of the newest assistant professors in the department, formally starting my appointment in January of this year. And so I'm going to take the next 10 to 15 minutes to tell you a little bit more about my background, where I'm from, and what I hope the Dudley Research Lab is going to be doing. So I've been motivated for a long time by the idea that we can harness biology to generate sustainable chemicals. And using enzymes depicted in this metabolic map, these chemistries are happening in every cell of your body and in microbes, but I'm particularly interested in leveraging that to make useful things. For example, low value, high volume commodity biofuels, commodity chemicals, polymers, or much of my experience has been in making high value medicines and similar types of things. So to kind of echo Eric's introduction, my sports allegiance for now remains with Nebraska for most sports. But this mindset of biology as a tool for chemical manufacturing, I developed in my PhD, which was at Northwestern. Using microbes and as well as the extracts, these cell-free extracts to do complex metabolic transformations. And then I did this adventure abroad to the United Kingdom, and that's where I really built this expertise in plants and using these as an alternate bioproduction platform for making molecules. And I actually also want to point to, before starting my position at UW, I spent some time in industry. And that's been very helpful in my mind to see some of the challenges that I was experiencing in my academic research and to see that industry is also having many of those same challenges as well. And so that was very useful to see how the company Calyx was trying to engineer plants, specifically a type of plant that could grow more like a microbe in a bioreactor. I did a brief stint in science funding, and then again, as I mentioned, have started the Dudley Lab in January. And then just to introduce myself a little bit personally, I have 4 little experiments at home that take up a lot of time, including we have a new baby, 2 months old here, but we're still trying to get out and enjoy the great state of Wisconsin. So this was our first effort on the Ice Age Trail 2 weeks ago, 2 hours north of here. And really enjoy the outdoors, particular passion about downhill skiing. My other great love is history and learning why the world is the way it is. And so 4 years in Europe was, my wife generously went to many, many, many historical sites with me. So love to geek out about that. But what's the lab going to be doing? Well, we're really interested in plants because plants are amazing chemists that make a wide variety of useful molecules, some of which are depicted here. Many of these have bioactivities, so useful as medicines. One particular compound that I'll direct your attention to is this chemotherapy drug, vinblastine. It's made natively in this Catharanthus roseus plant, but in very small amounts. So there's benefit to a chemical engineering approach to take the genes, in this case, 29 enzymatic steps, and put those either into a microorganism or a plant that we can better control to be able to produce high levels of this valuable molecule. And other similar compounds in this class also have bioactivities. So this is one of the areas of metabolism that my postdoctoral research was really focused on. But why plants? You know, in some cases, you could imagine wanting to take the genes for this molecule and putting them into a microbe. But there is challenges there. Specifically, you know, plants have evolved to accommodate some of these complex pathways. So rebuilding them in a plant that is easier to manipulate could give you some advantages. And what I'm really excited about is that we can kind of bypass the need to isolate sugar that can then go into feed microorganisms. We can make everything in one organism that has really interesting ways to scale with agriculture, and it's taking its carbon directly from CO2. So I think there's some really interesting sustainability benefits there. And so that's what one of the main project areas of the lab is going to be, is building improved tools for manipulating the metabolism to make useful products. And so one of the plants that is going to be a key workhorse in the lab, I'll introduce to you now, and it's this species of wild tobacco. It's called Nicotiana benthamiana, and it's useful because we can really easily put genes into this plant and temporarily turn them on. And that's really useful for being able to see how we can test different enzymes, different combinations, ways to regulate them. But then if you wanted to create a plant out in a field or in a greenhouse that is making this activity, you're able to do so. So this plant, not only as a prototyping method, is useful, but you can also, there's some interesting applications to make useful therapeutic proteins or vaccines directly in this plant in more of a greenhouse-based bioproduction system. So for my lab, what we're doing, rather than putting medicinal proteins into this plant, we are putting each of the enzymatic steps. Here's those 29 enzymes that I mentioned for vinblastine. We're going to put those into this plant and then make some molecules, but there's challenges. You don't always make just the molecule you want in sufficient quantities. You also make these byproducts. And so that raises, you know, this area of manipulating plants has benefits, but it also has substantial challenges. And I'm trying to leverage this synthetic biology approach where we're trying to make the modules that manipulate gene expression more modular and more engineerable. And that mindset is called synthetic biology. So some of the challenges that my lab will be working on would be addressing plants have slow experimental workflows. It takes a long time to put a gene into a plant, do the tissue culture to then generate it. And so that's where my lab will be working on developing gene editing tools based on plant viruses that shorten this timeline. I'm also interested in these missing genetic tools. How do you turn a gene on or off at the level you specify in every single tissue throughout the plant's lifetime? And I like these cartoons that show, you know, almost an electrical engineering diagram that we would like to build. But rather than having each of these be electrical circuits, these are genetic circuits where a given protein turns on another one and ultimately turns on our bioproduction enzymes. And so we'll potentially be building these genetic toggle switches to better control that, or adding feedback loops to get the effects and the dynamic range that we'd like. And finally, as I mentioned, plants are amazing chemists, but we still don't know how they're making all of these metabolites and how they're regulated. There's tons of sequencing data out in the world, but we just don't have the experimental workflows to query that. So that's where there's this need for high throughput characterization and prototyping strategies. And that sets up the second project area in my lab, which is using cell-free systems for prototyping, bioprospecting, and improving enzymes. And so these cell-free systems are really an area of expertise I developed in my PhD, where you can take the lysate of an organism. So you break a cell open, it has the ribosomal machinery to take DNA. The monomer building blocks of proteins are amino acids. You add a source of energy and you can make a protein in a test tube. And this workflow is really amenable to liquid handling automation. And so then, rather than testing a handful of enzymes in one PhD career, you can test plates of enzymes in much shorter workflows experimentally. And so we're hoping to use some of these Project Area 2 experiments to feed back into Project Area 1. And some of the ways that might happen is discovering enzymes that help give more product into our pathway, to do machine learning guided enzyme engineering in a more rigorous methodical fashion, or elucidating how different genes are regulated in plants through these things called transcription factors. And so this will be the area that one of my first students, Sarah Noga, who's joined the lab, will be working on developing cell-free systems that are better at expressing plant proteins. And I'm also going to be having a visiting scholar coming from Poland that has experience in these plant suspension cultures, so new ways to make these lysates more effective at plant enzymes. And the last more future direction that I'd like to just throw out is that, right now we're making using organisms to make these molecules, but I'm imagining a future world where let's just dispense with keeping the cell, whether it's a plant or microbe, alive, and just daisy chain enzymes together in complex metabolic cascades. And that could have benefits where all your metabolic resources can go towards product rather than keeping your cell alive, and you have fewer toxicity constraints. And so I'm seeing this as, if I imagine where chemical engineering or biochemical engineering is going to be in 50 years, I think there's going to be a lot of Project Area 3, and that's an area that I hope the lab grows into. So I'll just finish that. I think plants are a really exciting new frontier for biological and chemical manufacturing that help us with some of the big grand challenges that we're facing as a society. So we can make a distributed, sustainable post-fossil carbon society. Some of the grand challenges that the lab might contribute towards are, getting more biomass out in the fields, making new to nature carbon fixation pathways, plants that can respond to environmental cues, maybe making your agrochemical on demand, and improving human health along the way. So with that, I'll finish up, and I think we're saving questions for the end, but excited to have a growing lab and be part of the Wisconsin-CBE community.
Thank you very much, Quentin. So I know we're coming up right at 12:30. So for those of us who have to leave, thank you for joining us. Otherwise, we're happy to take some questions on any part of the presentation today. And Mike, I don't know if you have any to get us started from the chat or the pre-question.
Yeah, thanks, Eric. So I have a couple that are from questions that were submitted when people registered. And the first one I'll actually address. The question was, are the labs available to tour and see if we're back in Madison over the summer? So I want to invite anybody and everybody who's making their way to Madison either this summer or fall. We'd be happy to give tours. I think one of the things we talked about, one great benefit of the new lab space is that because of all the glass, you can see into the labs while the groups are in there working. So we don't even need to go into the labs themselves to see how much is improved in that lab space. So anybody who's interested, let us know. One question, and we hit on the new building earlier a little bit, but one question that was submitted was, does CBE plan to request space in the new building so that more students can be admitted?
Yeah, that's a great question. So we definitely, Brian alluded to this a little bit, as you mentioned, Mike, are requesting and working to design new spaces within the new College of Engineering building. There are also part of that building large instructional spaces as well that'll be able to be used by any department in the college. So we definitely will not be limited by classroom throughput in order to be able to grow our program. Along those lines, our instructional laboratories will remain in Engineering Hall, which is why we invested in really making world-class facilities. And those instructional laboratories, I didn't mention it in this town hall, but we expanded by about 50% or 60% in footprint. And so that also is going to allow us to expand our enrollment should the demand be there.
Excellent. Another question that just came in through the chat is, where on campus will the new building be located?
Yes. So if folks can remember back to Engineering Hall, this is the one that looks like back-to-back E's if you look at it from the sky. There you go. Thanks, Quentin. So he's highlighting Engineering Hall, and then there's the mall out in front with the fountain and the old CAE lab, or some of you may have called it the old highway lab. That will come down, and that whole triangular area there will be filled by the new College of Engineering building.
Excellent. Another pre-registration question is, describe any applications for AI or GPU in upcoming CBE research.
Yeah, that's, those tools, both artificial intelligence tools and machine learning tools, Quentin mentioned it a little bit in his presentation, are being widely used in research areas throughout the department. The problems may change, but the methods are both being developed and applied to those problems that the CBE researchers work on. I'll also point out that as part of our continuing curriculum revision, we are now teaching a statistics for chemical engineers course within the department, and that course itself has training modules dealing with things like machine learning, so that people know how to use statistical approaches and modeling-based approaches to solve their chemical engineering problems.
Excellent. I'll have one more question here. This one can go for Brian. The question in general is, what's going well and what are the goals? I was wondering if maybe you'd be interested in talking a little bit more about kind of how we're positioned for moving forward and what the process will be in the next year or so to do the strategic plan.
Yeah, so I think Mike alludes, every 5 years or so, the department goes through an exercise to craft specific goals for the overall department, including every aspect from curriculum to staffing to climate. And so that existing document will come to its conclusion in 2025. And so with a new dean potentially coming on board here sometime in the next, say 12 months or so, the time is right for us as a department to get ahead of that leadership transition and say, what is it that we want to do as a department for the next 5 years? And so kind of going right from where you were starting, we've got great momentum. The activities and the goals that were set by Regina and Eric and were executed by them, we hit a very large number of those and hit them out of the park, not just, barely squeaked over the bar. So the momentum as a department in terms of faculty hiring, renovations, the development of a climate that I think is really, really exciting for students, faculty, and staff. All of these things are great foundations for us to continue. And so places where we perhaps didn't do as much work because we were quite busy with these other things is in the curricular area. So I mentioned earlier that that's something I think that with new facilities and capabilities coming, we should be thinking strategically about how to best use those to deliver the education to students, both at the undergraduate and at the graduate research level. So yeah, I think that's probably our big focus. Continued growth. Obviously, we would like to see more faculty come in. The program growth and its sustainability are always goals. And again, re-strengthening and fostering the climate that everybody really loves to be here and be part of this family. I think that's something that we'll focus on.
Awesome, thank you. Another question for Quentin. What collaboration opportunities will the Dudley Lab have on campus with other departments and businesses?
Yeah, one of the reasons that I was really excited to accept the offer here in the CBE department is I think within the department, there's a really nice critical mass of synthetic biology. So this mindset of being able to manipulate biology with chemical engineering principles. So and the new Bloomkey family lab shared lab space. So all the folks in there, that'd be Dr. Flieger, Dr. Schuster, Dr. Palachek, and my No is one of the newest faculty. I can imagine overlaps with them. But also I'm situated at, University of Wisconsin, a powerhouse land grant university with large departments in botany, in plant pathology. The agronomy and horticulture departments recently merged. So I'm making connections with the broader plant community. Was out last week at the Wisconsin Crop Innovation Center, which is a former Monsanto facility that they donated to the university to do high throughput crop transformation. There's more people on campus than I have time to meet. So I think a lot of opportunities that I'm excited about.
Sounds great. Those are all the questions that I've seen either with registration or in today's chat.
Great, thanks, Mike. Well, thank you everybody for coming and having a little time with the department, and we hope to see you again soon. We'll have a fall town hall, and please look out for those invitations. If you're interested on seeing a little bit more about the department, please reach out. We have a YouTube channel where a lot of the instructional laboratory grand opening video is there. We have all the town halls saved there, so it might be nice for you to explore if you want to learn even more. So thank you again and have a great weekend.